going to discuss probability. So we're going to take all of those ideas of counting principles, permutations, and combinations and use them to calculate probabilities today. So first of all, let's talk about probability itself. So with probability, you're either getting a success or you're getting a failure. Now, a success doesn't always have to be a positive event. It just needs to be what the desired outcome. So maybe you don't want it to rain tomorrow, but you're looking at the probability of it there to be rain tomorrow. So the idea of rain becomes our success. Even though it's not what we want, it's still the outcome that we're looking for. So it's our desired outcome. So our notation for probability, we use a capital P, and then we put what our success should be in here. So this reads the probability of success is equal to. So now this is where all of our counting principles come into play. We have to count how many different ways we can get a success, and then we divide that or compare it to the total number of possibilities. So you can see that we're introducing F in here. Now F is our failure. So all of our successes and all of our failures will make up our total possibilities in the denominator. So this is what we are looking for. This is the total number in our event that is going to occur. So if you wanted to find the probability of failure, same idea, but we're going to put our failure totals on top divided by our totals of success plus failure in the denominator. So let's look at a problem. So it says Roman has a collection of 26 books. That's the total. 16 of those books are fiction and 10 are nonfiction. He randomly chooses 8 books to take with him on vacation. What is the probability that he chooses 4 fiction and 4 nonfiction? So the fact that I have 2 possibilities makes this problem have 2 events. So when I use and in my event, I know I'm going to need to multiply those 2 events together. So the first event is finding how many ways we can pick 4 fiction books and then how many ways we can pick 4 nonfiction books. So I'm first going to calculate what my success number is going to be. So my success number, so I first have to identify, does the order matter here in which I choose the books? Since the order doesn't matter, I know these are going to be combination events. So my success would be that he chooses what he wants. So how many ways out of 16 fiction and 10 nonfiction can I pick those 4 books? So those are going to be combinations. I'm going to take the combination of 16 books and he chooses 4 of them, and the combination of having 10 nonfiction books and he chooses 4. So this is showing us the total number of successes. So when we do these calculations, this gives me 1,820 times 210 for 10 combinations of 4 for a total of 382,200 books. Now this is what my success is. Now I have to calculate what my total is. So what is the success plus failure? So the total is that he has 26 books in all and he just needs to pick 8 of them. So that, again, I'm not worried about the order in which we choose the books. So that's going to be a combination problem with 26 total books, and we're choosing 8 of those. So when I do that calculation, 26 combinations of 8, I actually get 1,562,275 choices. So now let's set up our probability. So the probability that he would pick 4 fiction and 4 nonfiction books is the success, which is 382,200 divided by the total, which is 1,562,275. We take that to decimal form, that's approximately 0.244, or maybe 24.5% if I take that out one more decimal. So this is actually the probability but sometimes they'll ask for the percent. Now notice that probability number is a decimal. Your probability numbers should range between 0 and 1 when you get a probability of success or a probability of failure. Any probability that you're looking for can go as low as 0 and as high as 1. You can never have a probability over 1. So the closer you are to 0, the closer you are to not really going to occur or not likely to occur. But the closer you get to 1, the more likely you are to occur. So it's a range of numbers. So you kind of have to identify where you are when you find your probability. Okay, so let's look at our second example. It says for next semester, Alyssa has signed up for English Pre-Calc, Spanish, Geography, and Chemistry. So she has 1, 2, 3, 4, 5 classes she's signing up for. If classes are assigned randomly and each class is equally likely to be at any time of day, what is the probability that Alyssa's first 2 classes in the morning will be Pre-Calc and Chemistry in either order? Now, for those 2 classes only are we worried about in either order, because obviously this is the arrangement of classes. So since we're talking about the arrangement of classes, this is going to be a permutation problem. Now again, this is going to be 2 events. It's that she gets what she wants in the first 2 periods, and then how does she arrange the last 3 periods. So our success here is going to be the permutation. So she wants pre-calculus and chemistry first, so we're arranging those in two choices and 2 arrangements of pre-calculus and chemistry. And then the second grouping of classes would be the other classes. That's going to be her Spanish, Geography, and English courses. So we're going to group those together. So we're going to figure out how many ways we can put those in order. So that's 3 permutations of 3. So this is the success. She wants pre-calculus and chemistry first, so she's arranging 2 classes in order, and then she's looking at the 3 classes secondly. So we're going to look at those, and we're going to do the permutation of 2 taken 2 at a time is 2. The permutation of 3 taken 3 at a time is 6. So her total number of choices for how she arranges those classes is 12. So now we've got to figure out what is the total altogether. So altogether, she's arranging 5 classes. So that's going to be the permutation of 5 classes taken 5 at a time. And that calculation will simply be 120. So now let's go and do our probability. So the probability that she will get she will take her pre-calc and chem first, and then our other 3 classes second would be 12 out of 120. Now that's going to simplify to be 1/10 or 0.1. Now if we needed to write that as a percentage, that would be 10%. But we're just going to keep it as a decimal. So you can see on our scale of probability, 0.1 is going to fall over here. So it's not very likely that that would happen, but it is a possibility. So that's how you're going to calculate your probabilities. You're going to take the number of successes and divide it by the total number. Now, what does a probability distribution look like? So the probability distribution maps the sample space to probabilities. So we talked about sample spaces in a previous lesson where we write out all of our possible outcomes. So if I look at this scenario, this is the scenario of rolling 2 dice. So when I roll 2 dice, our sample space gets to be very lengthy. So in our sample space, when I roll 2 dice, I can get a 1 and a 1. I can get a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. I can then get a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, and a 2 and a 6, and so forth. So I'm going to just continue this very quickly. 3 and a 5, 3 and, whoops, what did I do? I missed the 3, didn't I? 3 and a 4, 3 and a 3, 3 and a 4, 3 and a 5, 3 and a 6. I can get a 3 and a 7, or 4 and a 7. No, I'm all over the place right now. A 4 and a 1, a 4 and a 2, a 4 and a 3, 4 and a 4, 4 or 5, and a 4 and a 6. She can roll a 5 and a 1, a 5 and a 2, a 5 and a 3, a 5, 4, 5, 5, a 5, 6, and last, a 6 and a 1, a 6 and a 2, a 6 and a 3, a 6 and a 4, a 6 and a 5, and a 6 and a 6. So this is what the sample space looks like for rolling 2 dice. Now, in this scenario, what they're specifically looking at is the sum of the 2 dice. So the sum of the 2 dice would be a 3, a 2, a 3, a 4, a 5, a 6, and a 7. A 3, a 4, a 5, a 6, a 7, and 8. A 4, a 5, a 6, 7, 8, and 9. So I'm just adding those 2 numbers together. So what I've already had done for you is I've had this put onto a histogram so that you can see that I have 1 plus 1 is 2, but it's the only time I get a sum of 2. So I only have 1 2 out of 36 possibilities, so that would give me a probability of 1 out of 36 to roll a sum of 2. If I wanted to know what the sum of rolling a 3 is, well, that would be a 1 and a 2 and a 2 and a 1. That's the sum of 3. So that's going to give me 2 out of 36, which reduces to 1 out of 18. So you can see that I'm increasing my chances with a sum of 3. I'm increasing to 4, to 5, to 6, to 7. So you can see here that I have more chances of rolling a 7 than any other pair of numbers together. 2 being the smallest and 12 being the smallest, with just 1 in both of those categories. So if you look at some of the Vegas rolling games, the dice games, they're going to use this information to decide how much a payoff is when you're rolling the dice and you're trying to find different sums and different numbers that pop up. So this histogram is simply showing you how many of each, and what it has done is it's taken the sample space and mapped it out into a graph for us. So that's what the distribution looks like as a graph. This is what that same distribution looks like as a table, where if you look at the sums, for a sum of 2, there was 1 chance out of 36. For a sum of 3, there were 2 chances out of 36, but that reduces to 1/18. So this is what a probability distribution looks like. Notice that all of these probabilities are between 0 and 1. In fact, if I add all of these probabilities together, they should give me 1 because I've included the probability for each situation. So that's what probability distributions look like, and then you can use those tables to find the probability of different situations. All right, I'm going to give you some practice problems to do to practice those probability ideas today. So you're going to have the probability of success out of the total, even the probability of failure out of the total. Now your book is also going to talk to you about an idea called odds. Now odds are slightly different than probability, because probability of success is the number of ways you can get a success out of the total. That's what probability looks like. When you hear odds, some people think that odds mean the same thing, but odds actually mean that you're comparing similar ideas, but the odds compare the successes to the failures. So how does that work? So if I have a probability of success that is 1 out of 3, that means the odds of success would be 1, and then that would be out of 2, because if 3 is my total, 3 minus 1 means that I would have 2 failures. So odds compares successes to failures. And that's how it's a little bit different than probability. Now, if I give you that the odds of an event are occurring are 2 to 5, then the probability of success would be 2 out of 7 because you're taking the total number.
Juniors